Welcome. Let's take a look at finding the equation of a tangent line to a curve at a specific point where the curve is defined implicitly. So first we're going to need to find the derivative with respect to x, the rate of change, the slope of the tangent line, before we can actually find the equation of that tangent line. So we start by finding the derivative, or the rate of change, or the slope of the tangent line, by taking the derivative with respect to x on both sides of our equation. So on the left-hand side, we have the derivative with respect to x of 4e to the xy minus x equals, and on the right-hand side, we take the derivative with respect to x of 0. On the left-hand side, we're going to need to use the difference rule. So derivative with respect to x of 4 times e to the x times y minus the derivative with respect to x of x. And then we have on the right-hand side the derivative with respect to x of 0. Continuing on, for our first term, we need to use the constant multiple rule. 4 is a constant, so we can rewrite this as 4 times the derivative with respect to x of e to the xy minus the derivative with respect to x of x, and then the derivative equals the derivative with respect to x of 0. So at this point, we can start taking derivatives. We'll have 4 times, and now to do the derivative of an exponential function, we know that the derivative of e to the x is e to the x itself. So I'm going to keep this power. That's like saying e to the x is e to the x, and then we need to take the derivative of that power or that argument. So the derivative with respect to x of x times y minus the derivative with respect to x is 1, and the derivative with respect to x on the right hand side of 0 is 0. So at this point we have 4e to the xy. Now to find the derivative of x times y, we're going to need to use the product rule. So this is going to be the derivative with respect to x of our first factor, or x, times our second factor, or y, plus the derivative with respect to x of our second factor, y, times our first factor, x. Minus 1 equals 0. So now we have 4 times e to the x times y, and inside our brackets here we have the derivative with respect to x of x. That is 1. So we have 1 times y plus, now we're taking the derivative with respect to y, the derivative of y with respect to x. So the derivative of y is going to be 1, but because we're doing that derivative with respect to x, by the chain rule, we need a dy dx. So we have 1 times dy dx for the derivative of y times x minus 1 equals 0. At this point, we want to solve for dy dx. So we need to do some algebra to simplify this, and we'll start by distributing the 4 times e to the xy through our square brackets. So we're going to get 4 times y times e to the xy plus 4 times x times e to the xy times dy dx minus 1 equals 0. Now again, remember we're wanting to solve for dy dx to be able to find that slope of the tangent line. So let's subtract the 4y e to the xy and add the 1 to the other side of the equation. So minus 4y e to the xy plus 1. So on the left-hand side, the first term is gone and the third term is gone. And we're left with 4x e to the xy dy dx equals negative 4y e to the xy plus 1. And now if we divide both sides of our equation by 4x e to the xy, we will have our dy dx and we will know what the slope of the tangent line is. So dy dx is equal to negative 4y e to the xy plus 1 over 4x e to the xy. So there's our slope of our tangent line. And now what we want to do is we want to find the tangent line to the curve at 4, 0. So we want to take this dy dx and we want to evaluate it at the point 4, 0. So that vertical bar and writing the point 4, 0 at the bottom is a mathematical shorthand for evaluating the function at that point. So we end up with negative 4 times 0 e to the 4 times 0 plus 1 all over 4 times 4 times e to the 4 times 0. So e to the 4 times 0, that is equal to 1. And in my numerator, 4 times 0 times 1 is going to give me 0 plus 1 over 4 times 4 times 1. So the slope of the tangent line at the point 4, 0 is 1 over 16. And now we're ready to write the equation of the tangent line. So just a quick reminder, the equation of the tangent line is equal to, or is represented by y equals my derivative at the point. So in this case, this is going to be dy dx at my point. My point is an ordered pair x naught, y naught, times x minus x naught plus y naught. And so in terms of the original point I was given, x naught is 4, y naught is 0. So replacing x naught with 4 and y naught with 0, we end up with our tangent line being y equals our derivative at the point 4, 0. That's going to be a number, and that number we just found was 1/16. So y equals 1/16 times then x minus 4. You can write the plus 0 or not, since it is a 0. So our equation of our tangent line is y equals 1/16 times the quantity x minus 4 plus 0. I hope you find this helpful.